This is the revision tutorial for MST question 5. A spherical triangle ABC has an angle A 45 degrees 30 minutes, side B 62 degrees 21 minutes, and angle C 75 degrees 22 minutes. Use the Napier's rule to solve the triangle. So first, we need to sketch the triangle first. There's the angle A, and this angle is 45 degrees 30 minutes. And then there's a side B, so somewhere this is angle B here, and the side B opposite angle B is 62 degrees, and 21 minutes, and angle C is 75 degrees and 22 minutes. So this is the spherical triangle. We are going to use a Napier's rule. So Napier's rule must have a right angle triangle. So one way to do a right angle triangle is from the angle C, go down and create a right angle triangle. So in that case, there are two angles now in C. Let's call this C1 here, and then this one C2. We are going to apply the Napier's rule to the left side of the triangle. Let's say this is V here. So apply the Napier's rule to the left side triangle. Let's say VAC. So let's draw the Napier's view. Okay, let's transverse the triangle. So I have this vector V here, the vertex V here. Okay, the first side is encounter VA. Then angle A, which is 45 degrees 30 minutes. Then the side B, which is CA now, which is 62 degrees 21 minutes. And then angle C1. Then the side CV. And don't forget the comma here. So this is the Napier's view on the left hand side. And then there's Napier's view from right hand side there. So this is equal to, this is Napier's view. So V at the center. So this is VBC now, or VCB. Okay, V triangle VCB here. So if you follow the Napier views, okay, the direction. So I'm going to get a BC on first one, then angle C2, and then BC, okay, BC here, and then after BC is angle B, then BV. So there are two Napier's view here, don't forget the com. So this is how you set up the spherical, triangle, and the Napier's view. Okay, now let's focus on the left Napier's view. I have yellow parts and two blue parts here. We know Napier's rule say that sine of middle part here is equal to the product of cosine of opposite. So the middle part is the yellow part here, and the opposite part are the blue part here. So we have now sine of CV, which is unknown to us, is equal to the product of the opposite, which is, because the A and CA are both on the lower part of the view, so you can find this cosine of com A and cosine of com CA. And these are the blue part, and this is the yellow part. Now cosine of com A, you can convert them to sine of A, cosine of com CA, which is convert them to sine of CA, and sine of A is 45 degree, 30 minutes, and CA is 62 degree, 21 minutes, and we find out the product is 0.6317, and so CV is sine inverse of this answer, and is 39 degree, 11 minutes, and that is the CV. So this is 39 degree, 11 minutes, and the CV, we know this already. Next, we are going to find angle C1, which we know the two green color part also. So according to Napier's rule, say we have sine of middle part is equal to the product of tangent of iteration. So the middle part is in yellow and the iteration part is in green. So in this case, since C1 is in the lower part of the view, so this is you need to use the COM C1 and the tangent part, there are CV on the top there, so tangent CV and tangent of COM CA. Now, sine of COM C1 is same as cosine of C1. Tangent of CV is just tangent of CV. Tangent of COM CA is actually 1 over tangent of CA. So this will give you tangent of CV, which have 39 degree 11 minutes, and tangent of CA is 62 degree 21 minutes here, and calculate, you have 0.4270. So we get C1 now. C1 is cosine inverse of the answer, which is 64 degree 43 minutes for C1. So C1 is 64 degree 43 minutes. Next, we're going to find out VA, which is highlighted in yellow. And we know C1 and CA already. So we can write sine of VA is equal to product of the cosine, and both are in the lower half of the Napier's field. So you have COM C1 and cosine of COM CA. Since they are opposite of VA. So we highlight this in blue here. And then cosine of COM C1 is the same as sine of C1. Cosine of COM CA is same as sine of CA. So C1 is 64 degree 43 minutes here. And CA is side B also with 62 degree 21 minutes here. And then we find out that this is 0.8009. So VA is sine inverse of the answer is equal to 53 degree 13 minutes. So VA is 53 degree 13 minutes. So this part is 53 degree 30 minutes here. Next, we are going to find the angle C2 first. We know angle C is 75 degrees 22 minutes. And we know C1 also from triangle VAC 64 degrees 43 minutes. So the difference in this case is 10 degrees 39 minutes. So we have 10 degrees and 39 minutes here. So I write 10 degrees 39 minutes. So C2 is 10 degrees 39 minutes. With these two, we are able to find the angle B now. So we can use the color code here, B, and then VC and C2 are in the blue region now, opposite. So we can see that sine of column B is equal to product of cosine of VC and product of column C2. So I have this column C2 here, cosine, product, cosine, and this column B. But we know that sine of column B is the same as cosine of B. Then cosine of VC, cosine of column C2 is the same as sine C2. So put in the value, VC, we know from triangle VAC is 39 degrees 11 minutes, and C2 is 10 degrees 39 minutes here. From here, we'll get 0.14325. So angle B is cosine inverse of this answer, and you get 81 degrees 46 minutes. That is angle B. That is 81 degrees 46 minutes. Next, we are going to find PV with the middle part yellow. Is the product of tangent of the adjacent now. So you get sine of VB is equal to the product of tangent. One of them is VC, and then the other one is angle B. So we have column B because angle B is on the lower half of the view. Both of them will know the value here. So this tangent of VC and tangent column of B is the same as 1 over tangent of B. So fill in the value, and VC is 39 degrees 11 minutes, and B is 81 degrees 46 minutes here, and this will give you 0.1794 Therefore, VB is sine inverse of this answer, which is equal to 6 degree 46 minutes. So this is VB, which we have 6 degree 46 minutes, and VA we found out earlier is 53 degree 30 minutes. Okay, just recall that we 53 degree 30 minutes here. So now we know what is AB now. So AB is a side C now, which is sum of these two lengths. So you get 59 degree 59 minutes. Okay, so I think we round up to 60 degree. Alright, so that will give you the BV 6 degree 46 minute here. Finally, we are going to find BC in yellow, and we have two opposite in blue. So we can write sine of BC. Say BC is below half, so we can count BC here. It's equal to product of cosine of the opposite, which is actually cosine of BV, times cosine of BC. Sine com BC is actually cosine BC here. And so this is cosine BV, which is 6 degree 46 minutes here. And VC, cosine VC is 39 degree 11 minutes here. So, and you multiply them out, you get 0.7697. So BC is cosine inverse of the answer, which is 39 degree 40 minutes. There's your BC. So this will solve the spherical triangle now, because it is 39 degree 40 minutes, and you also know the angle B is 81 degree 46 minutes. So all these are solved because we also find the C here is actually 60 degree. Alright, let's solve the spherical triangle.